discuss the relationships and how to show them with a Venn diagram, we're going to spend a little more time looking at Venn diagrams and also at another representation called a contingency table. For our first example, we're going to look at a Venn diagram like this that has two circles in it. And we'll just call them A and B. And we're going to shade the region representing the given sets. And my first set is A complement intersect B. So we'll start with B first. That's pretty easy. That would be this whole area inside the circle. And A complement would be the entire area that is outside circle A. So that would be here. And we're to find the intersection of those, so we're looking for the place where we see both red marks and purple marks. So I'm going to erase here, because that has only purple. And I'm going to erase out here, because that's only red. And so our answer is this region here that's part of circle B, but does not include the part where it intersects with A. So this is my answer. Let's look at another one. We're going to start with our same basic Venn diagram. And this time we're going to find A complement union B complement. Well, A complement is the entire area that's outside of A, which does actually include this part of B. This is all outside of A. And then B complement would be the area that's outside of B. So that would include this part of A. And so I can see now, this time we're looking for a union. So anything that's red or purple or both is part of my set. So the only thing that's not part of my set is this little area here that contains A and B. Pause the video now. Work on checkpoint 1. Next, we're going to look at a Venn diagram that contains 3 circles, or 3 sets, and draw a combination of those. So here's my Venn diagram, and I'm asked to find A complement union parentheses B intersect C complement. So just like in other parts of math, I'm going to work the part inside the parentheses first. So B intersect C complement. Well, C complement would be out here. And a part of C complement that is also in B would be this part. Okay, so we'll let this part go away. And now we'll look at A complement union this region. Well, A complement is anything outside of A. So that's a very large region. Well, that's not A complement, but this is. So now everything that is in A complement or in this B intersect C complement is part of my answer. And this is the part that is not part of my answer. This piece of A that is not in B and this little section that's also in both A, B, or all three A, B, and C. So pause the video now and work on checkpoint 2. Before we go any further, I'd like to show you another method that you can use to identify sets or combination of sets without actually shading everything, and that is to number each region that is made by these intersecting circles. So I'm going to call the whole universal set region 1, and then we'll go right across the top, region 2, region 3, region 4, and then across this middle section, region 5, region 6, region 7, and then finally this one, region 8. Okay, the order that you name the regions is not particularly important. Just make sure that every region is numbered. In a setup like this where I have 3 circles that are all intersecting, I'm going to have 8 regions. If I have just the 2 circles intersecting, I would have region 1, 2, 3, and 4. And I like to use Roman numerals to identify my regions just to make sure that I don't confuse them with, sometimes we write numbers inside circles to indicate elements of a set. So I use Roman numerals to distinguish from those Arabic numerals that I might use to indicate members of a set. A market researcher collecting data on 100 households finds that 81 have cable television, 65 have high-speed internet, and 56 have both. So let's build a Venn diagram. We have 2 things that we're looking at: cable television, high-speed internet. So I'll call this CT and call this HSI. When I'm building a Venn diagram, usually it's easiest to start in the center and work your way out. So they said that 56 had both, so I'll put 56 in this area. 65 had high-speed internet, but that includes these 56. So that's an additional 9. It said 81 have cable television. Well, that includes the 56, so 81 minus 56 gives me 25 here. And then I want to fill in this outside area, which would represent those who have no cable television and no high-speed internet. So I'm going to add all this together, and that gives me 90. So that means there must be 10 out here, since we surveyed 100 households. Now we should have all the information we need to answer any questions. The researcher wants to know the answer to these questions. How many households do not have high-speed internet? Well, all of these do, so it would be just the 25 and the 10. So a total of 35 have no high-speed internet. How many households have neither cable television or high-speed internet? Well, we already figured that out. It's 10. And then lastly, how many have cable TV but not high-speed internet? Again, we've already worked it out. We just need to look at the diagram to see that there are 25 that have CT but not HSI. So pause the video now and work on checkpoint 3. in this example, we'll build a Venn diagram with 3 categories. So I'm going to start with my 3 circles. And this says a researcher surveyed 67 business majors to determine which business-focused media websites the students regularly visit. The results are as follows. 21 visited Business Week. Well, that lets me know I need a Business Week circle. 20 visited the Wall Street Journal. So there's my Wall Street Journal circle. And 46 visited Fortune. So this is my Fortune circle. Okay, they give me some other stuff. I want to start again in the middle. These are the people that visited all 3 websites, and I'm told that that is 9 people. Now we want to go on to these next areas where they visited 2 websites but not the 3rd. So they tell me that there were 12 that visited Business Week and the Wall Street Journal. But I already have accounted for 9 of those here, so there's only 3 additional. 11 visited Wall Street Journal and Fortune. Again, 9 of those are here, which means there's 2 here. And then 13 visited Business Week and Fortune. 9 here, which leaves 4 out here. Now I can look at the totals for each website. Going back to the beginning, it said 21 visited Business Week. Well, I've got 7 and 9, 16, so an additional 5 to make the 21. 20 visited Wall Street Journal. So there's 12, 14. I would need 6 to make up the 20. And then 46 visited Fortune. Well, I got 6 and 9 is 15. So that would be an additional 31. And now I need a number for the outside. So I'm going to take, let's see, 31 and 11 for those 2. And then for these 3 would be 9 and an additional 9 for the center. So this is 20. That's 40, so that's 60. We had 67 surveyed, so there must be 7 out here that didn't visit any of those places. Now we can answer some questions. First one, how many students visited none of the websites? Well, we just found out that that was 7. How many visited only Fortune? So that would be this area here that didn't intersect with the others. So Fortune only. Would be 31. How many visited Business Week and the Wall Street Journal, but not Fortune? So this area is Business Week and the Wall Street Journal, but if we say not Fortune, then we can't count these 9. So Business Week and Fortune is going to be just 3. Pause the video now and work on checkpoint 4. Here's another example of a Venn diagram for 3 different characteristics that are symptoms of people who might have the flu. And it says, Mark McCloney, MD, saw 100 patients exhibiting flu symptoms such as fever, chills, and headache. Dr. McCloney reported the following information on the patients exhibiting symptoms. So we know we have a total of 100 patients. And we're going to be looking at 3 symptoms. And the symptoms are fever, so we'll call that F, chills, C, and headache, H. And it says of the 100 patients, 74 reported a fever, 72 reported chills, 67 reported a headache, and so on and so on. I'm going to skip down to the bottom. It says 3 reported all 3 symptoms. 35 reported all 3. So I'll put a 35 in here. And then they gave us a piece of information they don't normally give us. 3 thought they had the flu but did not report any of these symptoms. So we can put the 3 out here. Now let's go back and do these 3 regions. It said 49 reported chills and a headache. So chills and headache are here. 49 total in this area. We've already got 35. So just 14 more. And then they said 47 fever and a headache. So that would be this area, which already has 35. So to get to 47, we need 12 more. And then 55 reported fever and chills. We've already got 35, so we need an additional 20. Now we can go back up to the single symptoms. It started with 74 reported a fever. Well, this is 55, and another 12 would be 67. So to get to 74, I only need 7 more. And then 72 reported chills. So now I'm going to look at 20 and 35 is 55 plus 14 would be an additional 69. And so to get to 72, I only need 3 here. And then the last one was headache. 67 reported a headache. So we've got 26 here, plus the 35 will give us 61, so an additional 6 here. Just to check my math, I'm going to go ahead and add all those numbers up. Everything should add up to 100. So I've got 35 in the middle. I'm going to write these 2 together as 26. And then 20. So that's all those 4. And then I've got 7 and 3 is 10, and 6 more is 16. And then the 3 on the outside. So I've got 6 and 6 is 12, and 3 is 15, and 5 is 20. 5, 6, 7, 8, 9, 10, 100. So that's a good sign that I interviewed 100 patients, and I've got 100 patients on my Venn diagram. Okay, now that we have a good Venn diagram, let's see what we're supposed to find out. Actually, they didn't ask us to find anything out. They gave us everything. So we're ready now to go on to checkpoint 5. Sometimes it's not necessary to construct a Venn diagram to find out what we want to know. If we just want to know the number of something that's particularly in a group where there's only 2 categories, it might be easier just to work with the addition rule. For instance, a group of 10 students meets to plan a school function. All are majoring in accounting or economics or both. 5 of the students are economics majors and 7 are majors in accounting. how many major in both subjects? Well, I'm going to do just a real quick little Venn diagram here. And we're going to call this economics. And this accounting. Well, economics had a total of 5. So 5 between here and here. Accounting had a total of 7 between here and here. But there were only 10 students. So there has to be an overlap here of at least 2 students, and then that would make this 5 and this 3. So now I've got my 5 students in economics, I've got my 7 students in accounting. So how many major in both subjects? 2. Now that wasn't hard to do with a Venn diagram, but there is another way to do it. It's called the counting rule. And we say the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Why do we have to subtract this? Well, if we count everything over here and everything here, we've counted this little region twice. We don't want to count it twice, we only want to count it once. So we subtract it so that we're only counting once. Okay, in this one, we knew that A union B was a total of 10, and we knew there were 5 in A and 7 in B, minus the ones who were double majors. Okay, so I do a little simple math here and I say negative 2 is equal to negative number of A intersect B. So there are 2 elements, 2 people in A intersect B. Okay, so if I don't want to draw a Venn diagram, I can work the problem that way. Pause the video now and work on checkpoint 6. In our next example, we'll be looking at another representation of sets called a contingency table. And the example reads this way. The following contingency table gives the number in thousands of males, denoted M, and females, denoted F, who were working full-time, denoted A, working part-time, denoted B, or looking for work, denoted C, in the year 2016. Okay, so I'm going to make this into a table instead of a diagram. I'm going to have males and females, and then 3 categories, A, B, and C. And I was given these numbers. Okay, so here's my table, and they want me to find the number of people in the given sets. So set A, I would have to add these 2 together, and set A would be, move this over a little bit, okay, the next thing I want to know is F intersect A. So I'm going to look at column A and row F, and where they intersect is just this cell. So no calculation required for that one. How about M union C? For a union, I would have to do all of these and both of these, but I want to make sure that I don't count that twice. So it's going to be 7,567 plus 10,002 plus 41,87 and 35,65. So altogether, I get 88,321. And another way that I could do that is with that addition rule that I just learned. Okay, the number of males, I'd have to calculate that from this. And then the number here of the looking for work, I'd also have to calculate. So then when I put those together, 92,508, and then I would have to take away the part that overlapped, which is 41,87, and I would still get 88,321. Okay, so either way you can work that one. And look at one more. B union C intersect F. Well, B union C, I would have to do this and this all together and then count only the ones who were females. To me, it's simpler to just look at these two. Both the B's and the C's, but only the females. So I would get 17,674 plus 3,565 and get 21,239,000 females who either worked part-time or were looking for work. Pause your video now and work on checkpoint 7.